All right, let's dive right into this explainer and explore exactly how XOOPS DebugBar 1.4.0 takes debugging from a completely frustrating guessing game and turns it into a precise, targeted science. Because, let's be honest, if you work with the XOOPS CMS architecture, you already know that just spotting a performance bottleneck is really only half the battle. This 1.4.0 update entirely changes how we track down that other half, the exact line of code that's actually causing the problem.
You know the feeling. We've all been there. You get a report that a page is slow. You load it up, and yeah, it is definitely dragging. But why? Is it the database? Is it some rogue script? Is it a caching issue? Historically, answering that single question could easily take hours of digging through files. Well, DebugBar 1.4.0 is designed to give you that answer in a matter of seconds. So here is our roadmap for today. 1. The precision update. 2. Macro metrics and time splits. 3. Pinpointing lines of code. 4. Deep diagnostics in SQL. And 5. Secure and actionable debugging. Section 2. Macro metrics and time splits. Understanding the user experience and server bottlenecks. Let's start right at the top with the macro view. This new RUM data flow, which stands for Real User Monitoring, acts like a telemetry beacon. It actually captures what your real administrators are experiencing, rather than just what the server assumes is happening. Because think about it, before 1.4.0, you might look and see that your server rendered a page in, say, 80 milliseconds, which sounds great, right? But if your user's sitting there waiting 4 seconds for a massive image to load or a heavy script to execute, your server metrics are completely blind to their pain. Now, the browser natively collects field vitals, things like largest contentful paint and cumulative layout shift, and transmits them right back using navigator.sendBeacon. That data then attaches directly to the matching stored profile, meaning you can finally compare server execution time side by side with real-world browser rendering. And this is where it gets really interesting with the new trifold bottleneck split. You now instantly know if you need to fix a bootstrap problem, tune a SQL query, or optimize your app code. In the past, you just got this one lumped-together figure for total request time. But if a request is entirely dominated by app time, spending 3 hours tuning your SQL queries isn't going to help you at all. On the flip side, if the boot time is huge, you know for sure you have a core bootstrap problem, not an issue with the specific module you happen to be looking at. This granular split even reports directly to your browser's native performance panel via the server timing header.
So, a huge win here in the analytics view is the new per-request block cache split. Think about a really complex front page. If it renders 19 uncached blocks, it's paying a massive penalty for 19 separate block renders, each triggering its own unique database queries on every single page view. By explicitly splitting out blocks cached and blocks uncached, and then averaging them per module in the analytics table, you can instantly see if a module is just wasting vast amounts of resources by totally bypassing the block cache. Honestly, it's a huge relief to finally have this kind of visibility.
Moving along to Section 3. Pinpointing lines of code, call site attribution. 62. Just imagine the absolute nightmare of discovering an N+1 problem where 62 identical database statements are running on your page, just completely dragging the whole system down. You look at your performance tab, you see those 62 duplicate queries, and then nothing. You're just stuck guessing which loop and which random file is firing them off. In the old days, you basically had to hunt blindly for the source. But now, version 1.4.0 names the exact file and line number, like itemhandler.php line 255, which literally saves you hours of manual source reading. How does it do it? Well, it captures a trimmed backtrace with every single query, but it doesn't just dump a wall of raw data on you. It's smart. It drops the generic database drivers, the loggers, and the XOOS persistence layer, because those are never the actual code you need to fix anyway. The analyzer then groups the surviving frames by frequency. So going back to our 62 queries, DebugBar tells you exactly where they came from. 62 executions from itemhandler.php line 255. Boom, you know exactly where to go.
Section 4. Deep diagnostics and SQL explain assets and events. Let's drill even deeper into how XOOPS handles targeted SQL and script investigations. This update brings a revived on-demand explain button, and it uses a brand new SQL redactor. Security is obviously paramount here, so the browser never actually sends raw SQL back to the server to get an explain plan. Instead, the server uses a short-lived stash. But more importantly, the new SQL redactor rewrites string literals to empty strings and numeric literals to 0. So if you have a raw query looking up user ID 45, it becomes a redacted query looking up user ID 0. This guarantees, without a doubt, that no sensitive tokens, session IDs, or passwords will ever reach the disk or network during your diagnostic process. And the rest of the deep diagnostics toolset is just as impressive. These layers prevent those nasty front-end library conflicts and finally give you a straight answer on what your code is actually doing. The asset scanner physically reads your rendered HTML. So if a theme hard-codes a copy of jQuery and then a module loads a second copy, Asset Scanner flags it immediately, saving you from those really bizarre JavaScript initialization bugs. Then you have collect events, which solves the classic "is my hook even running" mystery by substituting an observable object right into the event table, meaning it times active listeners and spots the dead ones. Finally, collect templates puts an end to the guessing game of whether XOOPS is actually reading your custom theme override or just falling back to the default module file.
Which brings us to Section 5, Secure and Actionable Debugging, Keeping the Failed Closed Safety.
Before we wrap up this explainer, we definitely need to talk about how all this new diagnostic power stays locked down. Because all this data in the wrong hands, total vulnerability. Thankfully, all these tools maintain the strict fail-close safety that XOOPS is known for. Anonymous visitors are never going to see your diagnostic output or system paths. In 1.4.0, the access policy is completely centralized. To even see the toolbar, you absolutely must be an authenticated module administrator, and global XOOPS debug mode has to be set to on. Plus, all the actionable endpoints like the explain queries or the RUM telemetry now explicitly require post methods and are gated behind specific CSRF tokens like DebugBar RUM and DebugBar explain, meaning anonymous attacker literally cannot replay a URL to trigger a diagnostic event.
This whole update really boils down to one simple ethos: moving developers directly from symptoms to solutions. You aren't just getting a bunch of generic metrics anymore. You are getting a hyper-specific map that points directly to the exact file, line, and template that's causing your pain.
If you currently find yourself manually reading through source code for hours just to figure out where an uncached block or a duplicate query is originating from, DebugBar 1.4.0 is going to completely change how you work. So I'll leave you with this final thought. How many invisible bottlenecks are hiding in your XOOPS architecture right now, just waiting for you to turn the lights on?